build Docker image. So now let's take a look at how to build our own customized Docker image so that we can deploy our own system or application onto the servers. So first, let's look at our REST API demo. So it is the REST API project we created last time by using the ingredient entity in the MySQL database, where we provide a REST API for the ingredient to get by ID, pagination, and all the functionalities regarding the REST API calls. Now we're going to build a Docker image to create containers from this system, from this application. And then later on, we're going to push this Docker image to our AWS cloud and use EC2 instance to start this Docker container. Okay, so now let's take a look at. There are multiple ways to create Docker image. We can use Maven plugin by set up the plugins in the pom.xml file, but we are not going to do that way. We're going to do a more like traditional or official, how say that, like normal way. Okay, so by using Dockerfile. And Dockerfile is, you can think of it's a blueprint or it's a script that we will use for the Docker engine to create Docker images out of our own files and own applications. The Docker file has multiple different instructions. So by declare what you do during the build of the image, so the Docker engine will copy the files into the image and also set up the command and also run some scripts. That's the main idea, so that Docker image could be used to start any kind of application, not just only Java. Okay, but for Java itself, we also have multiple different ways, especially considering we are using Maven or Gradle, this management tools. We can set up different kind of Docker files in order to start our Java application. For this demo, we have two Docker files, and for like two different ways to start our Maven project. First one, okay, so is this run source. It's basically we're gonna put all the source code onto the image into the container, and then start using Maven. Okay, so we have a Spring Boot plugin, and we use Spring Boot plugin in Maven to start our the Maven project from the source code. Okay, which is I don't personally like it because you have to re-download all the dependencies from your image. This is the run command. So basically, what it does is just to download all the dependencies in the pom.xml every time we build the image, and then we put everything into the image and then start it. The second way is we pre-build our system in a jar file, and then we copy this jar file only into the container and then start the container using the Java command. Okay, jar. So I prefer the second way, so because it's easier and simpler to understand. Also, we don't want to always expose the source code in our images, so we can just put the jar file there. Okay, so but anyways, those two Docker files has something in common. First is they start with from. Okay, so this from is a base image that we're going to be using to build this image, build our own image. Okay, so this is actually a separate image which is pre-built by Eclipse. This includes the 17 version of JDK. Okay, we have different versions of JDK so that we can get it from the even GitHub to search like the corresponding JDK versions and different vendors. Okay, and then the second is the work directory. So this is to set up the which directory we can the command will be executed in. Okay, so for this one we have to change it to our directory. And then we have a copy command. So the copy command is basically copy from our local machine, okay, into the image file system. Okay, so basically you can see all those commands of copy. They are copying this folder into the same name folder inside the image. Right, so it's basically copy command. So you can see here it's copy the whole source folder into the source folder of the work directory. Okay, and here for this second one, okay, so we could only copy one file, which is the jar file, into our app.jar file in the container, in the image. Okay, So where is this jar file? Okay, from here we just copy the source code because we already have it from Git, right? So, but the jar file you need to build it by yourself. In order to build the jar file, we have to use the command called Maven package. Okay, so using this Maven package command, or we can just go to here and then go Maven and life cycle and then package. Double click on this. Okay, so then it will run all the test and compilation, and then finally create our jar file here. Okay, so then this is the build process, okay, of our project using Maven only. But during this package, we will it will run the test, and we have a database connected to it. So if somehow you didn't start the database, okay, so like for my here, let's see, I don't have the database started, right? So if your system is trying to connect to the database, it will fail because you don't have a database started. Just make sure that either you start it or you can use the Maven package command. Okay, so oops, I just built the wrong one, so that's why it's success. Okay, so let's just go into RestApi Demo. Okay, so make sure we are in the same correct folder. Okay, RestApi Demo. This is the folder. Now, if I run Maven package, and it will fail probably because I don't have the database started. You can see it said, okay, it's failed because the error is saying that your database connection is refused. Okay, so this is because of the database is not up. Okay, so in that case, our system cannot build this jar file. Okay, so this is a pre-built one. Let's just run the Maven clean. Oops. Okay, Maven clean. Okay, so then this target folder will be gone, and then let's just build a brand new one. Okay, so Maven package, and then it will fill. Okay, so then under the target folder, okay, we won't have the jar file that we need. Okay, it's not here. Here. Okay, so this is the target folder under this, and then there's no jar file. See, so either start the database. Okay, so start the database will make it work, make the test work, or we can use a Maven package, and then we just to -d, and then we try to skip the test. Okay, just type skip tests. In this case, it will just won't test our code. It will just basically build the Java file and then create the jar file. Okay, so now we have the jar file. So basically, the next step is we're going to run this Dockerfile, and then the Dockerfile will create an image and copy this file into the image. And then we also set an entry point saying that, like, once you start this image as a container, then this command will be executed. Okay, command is java-jar/app.jar. Okay, so then this is the our package. Okay, so basically we copy this one into the container, change its name, and then run it. Okay, you don't have to change the name. You can keep the same name. It doesn't matter. Okay, but this is the process. Okay, so now we use Maven to get this jar file. First step. Second step, create the Docker file and copy this jar file, okay, to the container, to the image, and then set up the entry point. Then the next step is we can create this image file. Okay, we use the Docker command. Okay, so to build the image, make sure we are in the correct folder. Same with the Docker file. Okay, here this is the Docker file. Okay, and then we can use Docker build command. Okay, and then we can give it a name. Okay, so a tag. We can just call it SEP REST API, for instance, and then we can indicate where our context is gonna be. Okay, so this is the current folder. So we use a dot. Okay, don't forget this dot. Okay, so it's not a period. In the tutorials, a lot of people miss this dot. It's not a period. It's just represent the current folder. Okay, so if you want to build using this Docker file, then you can also indicate like -f. This is the file, and I want to use this Docker file run source. Okay, so I want to use this Dockerfile to build the image. You can just use -f. But for us, we're gonna just use the default. Default is the same name, Dockerfile here. Okay, so we don't have to indicate the name, and they hit enter. It depends on your network because we have a base image there, so it need to be downloaded, and maybe it will take 1 minute or so. I already have it, so it was pretty fast, like in less than 2 seconds. Then the image is created. Okay, so now we can come to the desktop and then look at the image, and we will see here. Okay, so we have our SEP/RestAPI, right? So this is the name we indicate when we give the command. Okay, SEP RestAPI, and the latest version status never used, created just now, and the size is 500 megabyte. Okay, so this is the image we created. Now this image is sitting in our local computer, and we want to test it, right? So let's start a container, okay, out of that image. Now we only have those official images from third party, so we can run our Docker command to start our Docker container from our own image. Okay, we can use Docker-run command, okay, to start a new container. -d is like a daemon. We want to run it in the background. -p, which is the port number that we want to expose, okay, to our local host. Because if we don't expose the port number, probably we cannot call it, right? So the 8080 is the default Tomcat port, and then we can give it a name. We can just call it, let's see, testAPI. This is the container name. Okay, so the SEP/RestAPI is the image name, so they don't have to be the same. And then we give the image name. Okay, so the image is here, SEP/RestAPI. Okay, if you forget, just come back and look at the image. Okay, it will be here. Or you can type Docker images command. It will list all the images there. Okay, and this is here's the problem. If I start this container now, okay, what's gonna happen is we're gonna create an isolated environment, and our API or our Spring Boot project or this jar file will be started inside that isolated container, and that container is trying to connect to a database, which is by default is localhost 3306. All right, so then this database actually doesn't exist in the containers environment because the container is a standalone environment. It has its own network. If you try to connect to localhost 3306, what's going to happen is the container will try to connect to itself, right? So that's the localhost of the container itself. It won't work because now our real localhost, okay, is running the MySQL database. Even I started now, okay, even I start my localhost 330. This is a real MySQL database running, even in the Docker, but still in the localhost we have the forward. We can go from the localhost 330 to that Docker. But if I start this container right now, what's gonna happen is the Docker cannot find the database, even though we have a localhost database running in our real localhost, but in the localhost of the Docker container, we're gonna start now here, it doesn't have it. Okay, so it will have issue. It cannot start because you don't have database. We can try it actually if I hit enter. Okay, so this Docker container will be created. Okay, so and if we look at the containers here, right? So the testAPI, but it's in the exit status. It's not green. Okay, so it's because if you click on it, and if we look at the log, you will see caused by Hibernate issue. You can see Hibernate unable to create service, and then up there should be a connection refused. Okay, so this is because of the database cannot be found basically. Okay, so even though you're trying to connect to your database from inside the Docker container. So what we're gonna do is when we start the Docker container, we have to rewrite this URL, right? Because you're trying to connect to a real database, maybe in the remote server, maybe in some other servers, maybe in your local host. So you have to change this URL when you start a Docker container. Okay, so how to rewrite this? We cannot just change this here in the source code and then rebuild an image and then reconfigure your container, right? What if you want to deploy multiple times and for different databases. This work will be tedious, right? So what we can do is we can use this. First of all, we use this entry point command. So the entry point command will take whatever parameters after this command, after this docker run command. Okay, we can just put all the parameters here, and then it will be passed after this here. Okay, there's also a similar command called cmd. Okay, so if you're familiar with Docker, you know. So the cmd won't do the same. Only you can use entry point. It will take the command line parameter and append after this Java here. Okay, so but for here now we can do what? It's like when we start the container here. Okay. We can actually rewrite our Spring's configuration. Okay, so we can just pass spring dot blah blah whatever parameters you want to rewrite. Okay, you don't have to stick with the one that we hard coded in the parameters. Okay, even username, password you can change at the runtime. Okay, that's I mean not runtime but at the starting point. Okay, of the Docker image. Okay, so in order to do that, let's firstly let's firstly delete the existing one. Okay, so for here, this one doesn't work. Let's just remove it. I don't quite recommend to use the Docker desktop because it's convenient, but it won't get used to use the command line. So let's see if we let me just quit it. Okay, we can just use Docker ps-all. Okay, it will list all the Docker images here. Okay, and if we want to delete anything, you can just use docker remove and then just delete the Docker image using the names. Okay, same thing with Docker images. All right, so you just type Docker images and it will list all the images here, and then you can delete the image using Docker image delete. Okay, so anyways, we just use this for like a more visual and convenient. And here. For the image, we don't need to rebuild because the image itself is okay. We can, when we start the image, we're going to pass the parameters to rewrite the parameters of the Spring application properties. Okay, so what we do is we just go to this command and pass the parameter we want to rewrite. Okay, hyphen, and then spring.source.url and this part until. Okay. And then here we need an IP address of our local computer, not local host, but in the local network. You need to find your IP address. How to find it? For different operating system, we have different ways. You can Google, or the easiest way is you can just run this ifconfig if you are using Windows. Okay. And if you are using Mac or Linux, just the ifconfig, okay, and hit enter, you will see there's a lot of network interfaces there. So usually this IP address will show after the inet. Okay, so you can just go ahead and see. You probably won't have this many as mine, but you can just use this command grep and then inet. Okay, and then it will just search all the inets from this output, and just take a look. All those kind of like IPv6. Okay, so these are not real IP addresses. I mean, only mainly used for local like Docker virtual machines. So this one, okay, 192.168, or probably your IP start with a 10. Okay, so then that's your local IP address, and just copy this one and then put after the after this here. Okay, I'll just copy and paste it for like temporarily, and then I'm going to copy this command, put it here, and then copy this command, put it here. Okay, and then 3306/SEP training. Okay, missed 2 hyphens. So hopefully you got what I'm trying to do here. Okay, in order to start the local Docker container and connect to our another local container. Okay, so this is the way we use a localhost IP address to just bridge the connection. Actually, there are other ways. We can use Docker compose, right? Just like the way we start our Kafka. use Docker Compose, we can put multiple Docker containers together to start them at the same time. But that is only for local computer. And also we can use a network setup in the Docker. So two Docker image can be set up in the same network so that they can directly connect to each other. You don't have to use localhost IP address. Okay. But no matter which way, you get the idea. So in order to start a Docker container, you need to think about the network situation, the network connectivities, okay, and even the file systems. All right, so now if the container is successfully started, it will become green, right? So here, and then we can just start and look at the log. Everything is good. Tomcat started at localhost 8080. Okay, so then this is the log inside the container itself. Okay, even though it started with the localhost 8080, it started in itself. Because we have the port forwarding, we forward our localhost 8080 to the Docker's 8080, right? So that's why we can also use our localhost 8080 to access the API. API is ingredient. Okay, so now you see it works, right? So this API, it returns. All right, so that's how we build a local container image, all right, using Dockerfile, and also combining with the jar file created by Maven, and start a Docker image, okay, using Docker command in our local. So next we're gonna talk about how to push this Docker container, push this Docker image, okay, to a server, so that other servers can pull this image out, just like how Docker Hub is working, right? Docker Hub is a registry of the public images everybody can use, but in a company you should use a private repository because you only allow the internal usage. So yeah, I'll see you in the next video. Thanks.